Collision domains and broadcast domains exist because real networks had real problems. And to understand why these terms exist at all, we need to start with failure. Collision domain and broadcast domain are two of those networking terms that feel like pure exam vocabulary. And the reason they feel that way is because people usually learn them backwards. They're given definitions first, without ever feeling the problems that those definitions exist to describe. So instead of starting with definitions, we're going to start with failure. Because these two terms exist for very real reasons. They explain why hubs failed, why switches fixed one problem and routers fixed another. And also why large networks slowly turn into chaos. Networks don't fail randomly. They fail because of interference and because of noise. Let's rewind to early Ethernet. This is a shared Ethernet network. There is one physical communication medium, one long shared channel that everyone uses. If one device talks, it uses the channel. If another device talks at the same time, the signals overlap. And once signals overlap, the data becomes unreadable. This setup behaves like one room, one microphone, and everyone trying to speak into it. If people talk at once, nobody understands anything. That's a fundamental problem of a shared Ethernet. This entire shared space has a name. We call it a collision domain. And here's the important clarification. A collision domain is not about devices, it's about the shared communication space. If multiple devices share the same space, they can interfere with each other. So in plain English, a collision domain is a shared area where simultaneous sending can cause interference. If you're inside the same collision domain, you compete for the same talking turn. You have to coordinate, and collisions are very possible. But if you're not in the same collision domain, you can transmit at the same time and you won't interfere. So the rule is simple. A shared medium equals a shared collision domain. Now let's bring in hubs. A hub is basically a signal repeater. It doesn't understand frames, it doesn't look at MAC addresses or make decisions. Whatever comes in one port gets copied out of every port. This means that everyone hears everything, everyone shares the same medium, and everyone can collide with everyone else. So one hub creates one giant collision domain. If you add more devices, the problem gets worse, fast. This is where switches changed everything. A switch doesn't blindly repeat signals. A switch receives a frame, stores it briefly, and then forwards it out intelligently. That changes the physical reality of the network, because now each switch port is its own communication link. Each device gets its own private path to the switch. So the key statement is, every switch port is its own collision domain. This means that PC on port 1 can send and PC on port 2 can send at the same time, without interfering with each other. Switches don't speed up Ethernet, they remove interference. Now we switch problems completely. This is not about collisions, this is about broadcast. A broadcast is a message sent to everyone in the local network. It's like standing in the office and shouting, "Hey, does anyone have this information?" Broadcasts are necessary. One example is ARP, where a device needs to ask who has this IP address. That question must reach everyone. So broadcasts are not bad, but they have a cost, because everyone hears them. Here's the most common mistake learners make. A switch doesn't stop broadcast. When a switch receives a broadcast frame, it forwards it out every port, except the one it came in on. This means that multiple switches do not mean multiple broadcast domains. So the key sentence, and this is critical, switches break collision domains, but they don't break broadcast domains. In small networks, broadcasts are barely noticeable, but in large networks, with lots of devices, lots of ARP, lots of discovery protocols, every broadcast interrupts every device, consumes CPU, and consumes bandwidth. Too many broadcasts equals too much noise. Broadcasts aren't evil themselves, too many of them are. Now routers. Routers exist to connect different networks. And one of the most important things routers do is routers do not forward layer 2 broadcast. So a broadcast sent in on one side of the router stops there. It doesn't cross into the next network. That means that each router interface creates a new broadcast domain. Routers don't just connect networks, they separate noise. Now we're locking the distinction. Collision domain is about interference, about shared media, and is solved by switches. Broadcast domain is about reach, about interruption, and is solved by routers. Same word, domain, completely different problem. Here's the mental model to remember. Collision domain is who shares a microphone. Broadcast domain is who hears the loudspeaker. A switch gives everyone their own microphone but still uses one loudspeaker, where a router creates separate rooms and each with their own loudspeaker. Let's look it in clearly. Collision domain is a shared communication space. Collisions are possible and switches break these one per port. Broadcast domain is who receives broadcast traffic, switches forward broadcast, and routers stop broadcast. That's why switches improve performance and router control scales.